This video is on graphing sine and cosine functions. We're going to graph them onto the coordinate plane. On our y-axis, we're going to have numbers like 1, 2, 3, -1, -2. And on our x-axis, we're going to have radians, generally radians. Sometimes we'll put degrees on there. All right, so the first one we're going to talk about is y equals sine x. And if I make a table for that, so x and y, I'm getting these values from those the table to memorize from the unit circle. So for instance, when my angle is 0, sine is also 0. When sine is a half, is pi halves, sine has a value of 1. So you look, 0, 0, pi halves 1. When I have sine of pi, when I want to find sine of pi is going to be 0 again. And sine of 3/2 pi is at -1. And if you think about it, the coordinate grid, remember, so sine of 0 is 0, sine of a half is 1, 0, -1. That's where it's coming from when we were on the unit circle. And then if we go back all the way back around the unit circle back to 2 pi, sine has a value of 0 again. So that's as we go around the circle, that's where we're at. Oop, and then 3/2 pi, -1/2. Oh, sorry, -1, at -1. So as I go around the unit circle, all right, when I'm at 0 degrees, or sorry, 0 radians, sine is 0. When I'm at 1 pi halves, I'm at 1. When I'm at pi, I'm at 0, then down to -1, and then back to 0. And it keeps doing that wave up and down. So this is called your sine wave. People call it sine waves, and many things move like this. We say it moves periodically. If we go back to the negatives, sine of -1/2 is the same as sine of 3/2, because if we talk about moving in the negative direction, and negative pi is the same as pi, -3/2 is the same as pi halves, and then back to 0. And it always moves in that wave. All right, there's 3 things we define on a sine graph. Okay. The first is the amplitude. All right, we talk about the amplitude, and it's half the difference between a maximum and a minimum. All right, and I'll show you what I mean by that. All right, so here's a maximum, here's a minimum. Okay, here's a minimum. All right, and the amplitude is the half that distance, so not all the way down to there. Okay, not all the way down from one to the other, but this height right here. Actually, let's write it on this side. This height right here, that is my amplitude. Okay, and in this case, I have a height of 1. Okay, because it's a unit circle, the height of 1. All right, then we talk about the period. It's the shortest repeating section in a cycle. Okay, so if from here I go, I start at 0, 0. All right, so for instance, for ours, I start at 0, 0. I go up to 1. I go down to -1, and then I go back to 0. Okay, so that's from here to here. is my period. Okay, and it's the length of that. And in our case, it's 2 pi, because that's how long it takes us to get around the whole circle. Okay, a circle is 2 pi. And then the x-intercept, where the graph crosses the x-axis. So in our case, where y of, where 0 equals sine x. And every time 0 equals sine x is every time we hit that x-axis. So at 0, at pi, at 2 pi, at negative pi, at negative 2 pi, at 3 pi, at 4 pi, at negative 3 pi, at negative 4 pi. So everywhere there's a pi, we hit that. Okay, we hit that x-axis. All right, so for sine graph, we start at 0, we go up to 1, we come back down to 0, we go down to negative, and we come back to 1. And we do that when we go from 0 to 2 pi. And we also do that as we go from 0 to negative 2 pi. Okay, so that's the basic shape of a sine graph. Now we're going to talk about the basic shape of a cosine graph. All right, so again, we're still having amplitude, period, and x-intercept, but they're going to be different for the cosine graph. And if you look at that, that's what a cosine graph looks like. And if we go to a table, all right, we talk about x and y. Now, when radians is 0, the cosine at 0 is 1. Cosine at pi halves is 0. Okay, 1, 0. The cosine at pi goes back down to negative 1. 3 pi halves, we come back up to 0. And then at 2 pi, we are back up to 1. So we've just completed a period. And then we have the negative versions down here. Okay, we're kind of reflect. There's like a little bit of reflection of that. All right, so on this one, our amplitude is still 1. Our period is still 2 pi, because that's how long it takes to get around the unit circle, but our x-intercepts are different, because this is where cosine of x equals 0. So this is at pi halves, so it's at our halves. 3 pi halves, it's at negative pi halves, it's at negative 3 pi halves, it's at negative, or at 5 pi halves, at negative 5 pi halves. So this is where cosine of x equals 0. All right, and again, it's just, from that chart we had, okay? The values there. All right. So, again, it still has an amplitude of 1. All right, that's still my amplitude, and it still has a period of 2 pi. Oops. All right, so those are the parent graphs for cosine of x and sine of x. So what we're going to do now is we're going to shift them, we're going to dilate them, we're going to do all those things like we do to parent functions to get the specific functions. Okay. All right, so now we're going to talk about shrinking and dilating and making our graphs bigger. So dilations of our graphs. And I think, do we? Let me look at my examples. No, we do not talk about reflecting yet. So we're not going to talk about reflecting and translating quite yet, but we are going to talk about making it smaller and bigger. All right, the amplitude and period graphs of a equals sine bx and y equals a cosine bx, where a and b are non-zero numbers are. So when a was 1, it had an amplitude of 1. So when a was 1, it had an amplitude of 1. That, because it was just y equals sine x, that's always our amplitude. So our amplitude is always the absolute value of whatever a is. Okay, that's how tall I am from the x-axis, or how far do I move from it. So if that was 2 sine x, then I'm going to go up to 2 instead of up to 1. Okay, if it was, actually it was negative 2, I still do 2 because it's the absolute value. All right, the period, okay, so we're talking about this B right here, right? When it was just X was 2 pi. But our period now, if we put a number there, we're going to end up dividing it by B. Okay, so if that was a 2, all right, if it was like 2 pi, then we're only going to go a period of 5. All right, we're only, oh, sorry, of pi, not 5. We're going to go by a length of pi. All right. So all that information is that we talked about is right here in these two graphs. Okay. So and how to find everything you're going to do to find the middle. Now we're going to do half of the period. Figure out what half is, half of that, and in between. That doesn't really make sense until I do it. So let's do one, because I think I just kind of muddled that up a little bit. All right. The important part is to know what the amplitude and period will be. Okay, so let's do some examples of that. All right, so let's do an example. We're going to end up doing 5 examples. I don't know if I can fit them in the space. I might have to add another slide. We'll see how that goes. All right, so 1 equals y equals sine of 2x. Yeah, we'll only do 2 examples on here, and then I'll make some more slides. Y equals 3 sine 4x. All right, so let's do these. All right, so let's figure out our amplitude and our period. So our amplitude, remember, is going to be what A equals, and there's not a number there, so we're going to say it's 1. Our period, though, is going to equal 2 pi divided by B, and B in this case is 2. So 2 pi divided by 2, which is just pi. So now we're going to do a complete wave, starting at 0, going up, coming down, and coming back up in a period of pi, and not a period of 2 pi. So let's show you how that works. We're going to, when we go to graph these, I like you to do a positive period and one negative period. So let's draw this out. Here is my coordinate plane. My amplitude is going to go by 1, so I know I'm going to go, actually let's make this a little taller. Let's erase that. All right, we're going to go up 1, we're going to go down to -1, so I'm going to make that a 1. All right, so our period is now going to go to pi. All right, and if you remember from the sine graph, I went by 4s. I went up to 1, or started at 0, went up to 1, came down to 0, down to -1, up. So we got to split this into equal 4. So I'm going to do half of pi, which is pi halves, and then I'm going to do half of that again to get a 4th, which is pi fourths. And then halfway in between those is 3 pi fourths. So where did I get that? All right, this is the period length. This is 3/4 of the period length. But what it's easier to get 3/4 of the period length is actually find half first. All right, split it in half. And then do half of half, which is a 4th of the period. Okay, so we're still going to, the sine has a basic shape, and if we do the negative versions, we're going to do negative pi fourths, negative pi halves, negative 3/4 pi, negative pi. All right, and we're still going to say we're going to start at 0, 0, because that's where we start on the sine, up to 1, back down to 0, down to -1, and back. And then here we're going to do down to -1, up to 0, up to 1, and down. Okay, because that's the shape of a sine graph. Okay. All right, how do I know this is the shape of a sine graph? I have it memorized. I know what the shape of a sine graph, just like you're going to have it memorized. Start at 0, up to 1, back to 0, down to -1, back up to 0, and in the negatives we go down to 1, up to 0, up to 1, back down to 0. Right? The trick is going to be finding those x-intercepts, or those period lengths and 1/4 of that. So let's do another example. Let's look at this one here. All right, the amplitude is going to be 3, so now I'm going to go up to 3 instead of just 1 and down to -3. My period is going to be 2 pi divided by 4, which is pi halves. Okay, so now my period's even shorter. It's pi halves. All right, I'm going to draw my 2 periods. Okay, I'm going to go up to 3 and down to -3. I'm going to go to pi halves. All right, half of pi halves is pi fourths, and half of that is pi eighths. All right, so this is 1 pi eighths, 2 pi eighths, 3 pi eighths. I know here I'm going by eighths, because once I get that, I know all of these go up by eighths. A fourth is 2 pi eighths, and then 3 pi eighths, and then a half is 4 pi eighths. All right, let's do the negative version. Negative pi eighths. Whoa, whoa, whoa. Let's redo those marks. Those marks are kind of crappy. All right, half. Let's make this look pretty. All right. And then the sign, we start at 0. This time we go up to 3. We come back down. We go to -3. We come back. Down to -3, 0, up to 3, come back. And there's my two periods. One positive, one negative. All right, let's do 2 more examples. We're going to actually do 3 more examples. So example 3, example 4. All right, y equals 1/3 cosine 1/2 x. 4 is going to be y equals 2 cosine 12x. We're going to figure out our amplitude, and we're going to figure out our period on both of these and go for there. And now we're doing cosine. So with cosine, we don't start at 0. We start at 1, down to 0, down to -1, back to 0. All right, so our amplitude of this guy is 1/3, so I'm only going to go up to 1/3. My period is going to be 2 pi divided by 1/2, which equals 2 pi times the reciprocal, which is 2, 4 pi. Oh, 4 pi is equal to, easy to split in 4, easy to split in 4. All right, here's my graph. Here's 1 and -1. All right, I'm going to go to 4 pi and -4 pi. Half of 4 pi is 2 pi. I'm going by 1s, so this is 3. 2 pi, -3 pi. I'm only going to go up to 1/3, so I'm going to start at 1/3. I'm going to go to 0. I'm going to go down to 1/3. We'll come back to 0 and end at 1/3. Down to 0, down to 1/3, up to 0, end at 1/3. Kind of makes a W shape. All right, so that's cosine starts up. So sine, if you go back and look at those started at 0 and went up. Cosine starts at 1 and goes down to 0. All right, let's look at the amplitude of this guy. He's going to be 2. My period is going to be 2 pi over 12, which is pi 6. Oh God, I gotta split pi 6.5. Oh God. Okay, well let's do that. Who came up with this problem? I bet it was me. All right, here we go. Boom, boom. Let's see. We're gonna go up to 2. 1, 2, and we're gonna come down to 2. We're gonna go out to pi 6. Half of pi 6 is pi 12ths, because I did 1/2 times pi 6. Half of a 12 is a 24, and we're going by 24. So 1 24th, 2 24ths, 3 24ths. Oh, but 3 24ths is 8 thirds. Yep, thirds. Oh, God. 8 thirds. Okay, because that is 24 over 8. No, it's 3 over 24. So I'm going by pi 24, 2 pi 24, 3 pi 24, 4 pi 24, but everything's been reduced. Okay, negative versions of the same guy, except for I made that a lot shorter. Pi 6, negative 8 pi thirds, pi 12ths, pi 24. So again, to get my fractions, I go half, and then do half of that, and then that's what I'm going up by. So I did half of pi 6 was pi 12ths, half of that was pi 24ths, and then I know I'm going by 24ths. All right, cosine starts up, goes there, comes down, comes back up, goes there. Down, down, up, up. There's my W I'm looking for. Oops, let's make that dot bigger. All right, so there's my cosine. Y equals 2 cosine 12x. All right, one more example. Then I'll be out of your hair, and you can do your own work. All right. Did I go to the next slide without hitting? Okay, so I just did something different on this mix. Let's see if this works. Let's see what happens. I went to the next slide when I was still recording. Who knows how this is going to go? I don't even know. Tell me. All right, so example 5. Y equals cosine pi x. Dun, dun, dun. My amplitude is 1, because that's the number in front of cosine. My period is 2 pi over pi, which is 2. What? So I'm going to go up to 1 and down to -1. I'm going to go to 2. Half of 2 is 1. 1/2. 3/4. No, 3/2, because I'm going up by half. -1/2. -1. -3/2. -2. We're cosine, so we start up, down, down, up, up. All right, there's my basic shape, and I make my W. So that's cosine, and sine was shifting, not really shifting, but dilating and stretching, and we're just changing the intercepts and doing stuff like that. We'll talk about translation and stuff in a future lesson. All right, let me know if you have any questions.